Some of the most dangerous accidents in the world of transportation are not always related to collisions, speeding, or human error, but rather to unforeseen situations capable of turning an ordinary day into a scene of total chaos. Able to occur in seconds and without any prior warning, these are events where physics, weather, or a series of coincidences combine to create true ticking time bombs on the asphalt. We're talking about unexpected accidents. Situations that aren't caused by mechanical failures or poor driving decisions, but by phenomena that can catch even the most experienced drivers off guard. One of these unfortunate situations involves the dramatic implosions of tanker trailers. While it might seem curious to think how a giant metal structure designed to be ultra-resistant can collapse like an empty soda can, this phenomenon is made possible due to a pressure difference between the inside of the tank and the outside environment. Something that can be caused by various factors such as temperature changes or even human error. What you just saw is not a special effect. It is a real implosion caught on camera, an enormous metal tank collapsing in a matter of milliseconds. To fully understand this, it's important to know that these types of tankers are designed to transport both liquids and gases. Although they may appear solid from the outside, their structure is built to withstand internal pressure, not external pressure. That's why any significant pressure drop inside the tank, when surpassed by external atmospheric pressure, can cause the trailer to collapse in on itself. This phenomenon is most widely known in the underwater field. Implosions are one of the main concerns for marine engineers when designing diving equipment, as water pressure increases the deeper you go underwater, essentially surrounding the object with tons of water. In fact, pressure increases by 1 atmosphere for every 10 meters of depth. Unfortunately, one tragic situation where an accident like this occurred was during a June 2023 expedition to the Titanic, where the Titan submersible imploded due to the fragility of its structure and the use of materials like carbon fiber, which were not sufficiently tested for deep-sea dives. As for tanker trailers, the reasons for implosions are varied, but all lead back to this pressure imbalance. These causes can generally be classified according to the type of factor involved in triggering the implosion. First are physical and mechanical factors. One of the key variables is lack of proper ventilation, which occurs when there are no mechanisms or conditions in place to compensate for volume changes during vapor condensation, resulting in negative pressure that leads to an implosion. Another common cause of these accidents is sudden temperature changes. These can occur in different ways, one of the most frequent being an airtight seal at the wrong moment. If a tank is carrying a substance at high temperature and, after unloading, is sealed and begins cooling without releasing the remaining vapor, internal condensation will generate a vacuum, causing it to give in to external pressure. It's also worth noting that drastic temperature drops caused by environmental conditions, like a sudden drop in ambient temperature, can accelerate internal vapor condensation. There are also technical and operational factors directly tied to the tanker trailer's function and the control exercised by its operators. Lack of ventilation may also stem from poorly maintained relief valves. If these are clogged, broken, or improperly calibrated, they won't allow adequate air intake when needed. Similarly, improper handling of a trailer under unfavorable environmental conditions, such as driving in the rain, can also be a cause. Operator involvement is another key element, as mistakes during essential tasks like cleaning can also lead to accidents. These trailers are usually cleaned using hot pressurized water, so a mistake like spraying cold water directly after steam cleaning could lead to accelerated condensation. Filling or emptying processes that involve vacuum systems can also be responsible for these implosions. That's why many experimental implosion tests on tanks are conducted using vacuum machines. However, the human factor in these accidents often boils down to a lack of knowledge or training, as failure to follow proper procedures for loading, unloading, or cleaning tanker trailers remains one of the main causes of implosions. However, during long-distance journeys, truck drivers also often face unexpected and unconventional incidents caused by the whims of nature. One such case involves rollovers caused by strong winds. While not very common under normal conditions for most drivers, they pose a serious threat when transporting large loads in very specific geographic conditions. To begin with, this phenomenon occurs when several specific conditions come together. First, it happens during high-speed winds, especially in the presence of gusts that can exceed 80 kilometers per hour, which are considered very dangerous for most types of transport. Another key aspect is wind direction, as crosswinds can catch drivers off guard at any moment. These conditions are generally found in open areas such as elevated highways or bridges, where the wind can hit the sides of trailers directly. Likewise, geographic zones with mountains, canyons, or even tunnel exits are prone to channel and accelerate wind flow, causing intense gusts. Interestingly, and somewhat counterintuitively, in extremely flat and open areas such as treeless highways and deserts like those in Australia, the lack of obstacles allows wind to flow freely, increasing the likelihood of sudden rollovers. While the wind alone can be enough to cause problems, the risk of rollover increases when combined with other factors directly related to the characteristics of the trailer and the load. Since wind applies a strong horizontal force, large flat surfaces, such as enclosed box trailers, create a sail effect that compromises the vehicle's stability. Surprisingly, trailer design itself can play a key role in these types of accidents. Taller trailers, or those with less aerodynamic surfaces, are more likely to be affected by high-speed crosswinds. The risk rises significantly with trailers like tarps, elevated structures, or those with loose canvas coverings. Similarly, load distribution is another major factor in rollover incidents. If the center of gravity is too high, poorly distributed loads can shift easily, requiring less wind force to tip the trailer. This also happens when trailers are operated with little or no load, as they offer no real resistance to wind pressure, effectively turning them into giant hollow boxes that are easy to move or overturn. As for preventive measures, they typically focus on planning and operator training, which includes teaching drivers how to respond to these situations. However, one of the most common and effective solutions is the use of windbreak barriers installed along vulnerable highway sections. These barriers are designed to block some of the crosswind in critical areas, as can be seen on dangerous roads such as the well-known Rumorosa Highway in Baja California, Mexico. While implosions can be a genuinely dangerous phenomenon, what truly poses a greater threat are explosions. Although today everything is designed to operate safely and specifically to avoid this type of issue, it is well known that accidents are indifferent to any kind of prevention. This is the case with tire explosions, a phenomenon caused by a decomposition process called pyrolysis, which occurs when temperatures exceed 200 degrees Celsius. The problem is that once these temperatures are reached, the internal pressure of the tires can skyrocket, exceeding even 10 times the nominal pressure. As a result, inevitable tire explosions occur, which can have extremely severe consequences due to the unpredictability of such accidents, especially when it comes to heavy machinery tires. Reaching these extreme temperatures can be caused by a range of factors, from improper usage to unavoidable external conditions. The latter includes unpredictable situations tied to environmental conditions and natural phenomena such as electrical discharges. A clear example of this is what happened to a Cat 777 mining truck, which, while parked waiting out a thunderstorm, was struck directly by lightning. Fortunately, the operator was able to exit safely, as the cabin acted as a Faraday cage. However, the truck itself wasn't so lucky. It was a total loss. Another shocking example of how an electrical discharge can cause tire explosions is seen in this video. It shows another mining truck, this time a Cat 789, being towed somewhere in Russia. Unfortunately for the operator, the truck made contact with high-voltage power lines directly over a railway crossing, instantly triggering pyrolysis. The result, a tire flying hundreds of meters despite its massive weight and size. Although it's easy to assume that only external factors cause these types of accidents, the reality is that exceeding a tire's operational limits is one of the most common causes of explosions. Overloading or speeding can generate enough heat to increase internal pressure and ultimately trigger an explosion. The potential danger of these accidents is directly linked to the size of the tires. A practical way to understand the scale of such explosions is by watching tire inflation cage test videos. Here's an example of a farm tire inflated to 150 psi. Sadly, there's no completely effective way to prevent these incidents. The best thing operators can do is avoid unorthodox methods when mounting tires. There are countless viral videos online of people attempting to seal tires using explosive reactions. Because it's a method that relies on speed and agility and isn't 100% safe, it is irresponsible to recommend. That's why prevention, along with proper tools and knowledge, will always be the best option.